Hi guys. Everybody, hey, guys. So yes, statistics is not like algebra. There's going to be reading involved. There's going to be interpretation of what you find out. It's a little more than just throwing numbers around and getting number answers and not knowing what the hell they mean. Some of your teachers in the past maybe let you get away without putting units on something or explaining what something meant. That cannot happen in statistics because the units and what it means is a huge part of the answer. Chapter 1, I kind of warned you going in, that was full of definitions. So a lot of it should have been you reading through it, seeing if it jived with what I said in class, all this kind of stuff. There were questions that some people had about homework not quite matching up, but the homework hadn't even been checked yet, and there were some troubles with the homework, so you can't base things off of what you've done without knowing what you've done is correct, right? I've got office hours out there in the office. You guys can certainly come by there. You can always email me. A few people have done that, just to kind of double check. Everybody got my email about the next test, right?
Yep.
Okay. As soon as you get the quiz back, you'll see why. One reason why I decided to do that. Some of you guys are appropriately not laughing too much. I mean, not everybody did horrible, but it was definitely not the best showing ever. I am totally here to help with what you're trying to do. I am not here to always just hold your hand through every problem. I can't do that. You've got to start really trying to understand what something is and why it makes sense and why you see why we had to define it certain ways. We want to be able to talk about data in a way that tells me what I can do with it. So if I said I have interval data, I'm like, oh, I can't divide that shit because it won't make sense. I know I can subtract it. This is just a quick way for us to talk with each other. Those crazy ass math people. So let's go through this. There is that one part C. I did change it to be about weight, and I forgot to change that. It used to be about smoking versus IQ, and then I changed it to be a little more easier to handle. But still, part C. Let's talk about part C right now. Are the researchers working with a sample, or are they working with the whole population? They're working with a sample. So anything they find is going to be a statistic. Sample statistic is crazy. Some of you guys, I don't think quite heard that. It's amazing when math does that for you. Population is parameter, right? Sample is statistic. So if I have a number describing a sample, that is a statistic. If I have a number describing a population, that is a parameter. I love it. And a word that happens very often, but not all the time, is the word all. That word normally tells you it's a population. So when you write an answer for a population, probably should use that word all. An example I was given earlier was, if I said next door there, who's next door? And I said clowns. So there's some clowns in there, okay. But if I said, and you said who's next door, and I said all clowns. You're like, holy shit, man. Well, they fit in a damn little car. Maybe all clowns can fit in that room. I don't know. That's a lot. There's a difference between those. So using the word all is not just suggested. It's actually required to really make that distinction. We're talking about everybody. So part A, the sample, I asked you that first because it's normally easier to find the sample. What is the sample? Yeah, 256. Adult, male, Ecuadorians, I think is how you say it. Ecuadorians. Woo! 256 adult male Ecuadorians. What's the population going to be? All. You change that number. And again, I don't want you just to memorize that. Why does it make sense? Because what's the sample got to be? I always get people tell me the sample is, like they would say the sample is the link between smoking and IQ. No, the sample is a group of things. And where does the sample come from? It is picked from the population. So obviously, the sample and the population are going to share a lot of words. Because they're both the same kind of people or things. Just one of them is going to be a smaller group, 256, and the other one's going to be all. You can replace that number with the word all. Why does that make sense? Because of everything I just said. They've got to have the same description because they're the same idea. One is picked from the other one. So the population must have been all adult male Ecuadorians. It's just fun to say the word Ecuadorian. Okay, so basically it's easier, normally it's easier to find a sample if I give you like a specific group that was a sample. You can find it really easy. I talked to 80 Grossman, okay, 80 Grossman students, it's a sample. Then you normally can just take the number, and almost always that works, take the number, replace it with the word all, that matches the idea of what the population of the sample are. Don't just do it because you said to do that, replace the number with the word all. Ugh. Why does it make sense for that? Because that's the idea. Okay, I like it. So when you get done writing down the population, say to yourself, is that a group of things or people? Yes. Okay. At least that much is good. If you wrote down weight, is that a group of no, it's not a group of things or people. That can't be the answer. Are you guys with me? So population and sample are groups of things or people. Sample as a group that's picked from the population. I like it, I like it, I like it. Variable is related to the question. And data, I didn't ask you for data, but data would be all of the answers. I like it. In this case, numbers. I like it. They don't have to be numbers, but in this case, it would be just weights. So what is the variable? What would you ask somebody from the sample? What's your weight? So the variable is the weight of a male adult Ecuadorian. Of one male adult Ecuadorian. So what's the statistic has to be a numerical measurement of the sample. You gotta love that shit. We talk about there a statistics sample. So the statistic is gonna be what here?
The 256.
No, that's the sample. How do I describe the sample? What is it about the sample I want to find out? Yeah, so it would be the mean weight of. Yeah. So if I said that I wanted to find the percentage you drink, then the statistic would have been the percentage you drink, the percentage of. Write your sample in. But here's the mean weight of. Write your sample in, because what's the statistic supposed to do? Describe the sample. So once you wrote your sample, you can answer the statistic easy. You just copy that down in the right place. What is that I'm curious about these people? The mean weight. Okay, the statistics is the mean weight of 256 adult male Ecuadorians. Adult male, I'm just going to call them names. Adult male Ecuadorians. The entire right all again. And then what would the parameter be then? The mean weight. Look at this happening again. Of all adult male Ecuadorians. So again, I just traded the number for the word all. Because that's my population. So what can a statistic or a parameter be? At the moment, it could be a percentage or a mean. If you're not having one of those two words in your description of those things, you're not right. Does that make sense? I mean, so statistic and a parameter is the things I do with the data once I have them. And the two main things I could do numerically are, or even with qualitative, the percentage who have blonde hair, are means and percentages. So they have to be in there in the description. That's the main thing that they are. Okay. This one is a little bit wonky, but what is the... I think we already did this one, right? The researchers are working with a sample, therefore this will be a statistic. They have a sample they're working with. So that's all they could get. Simple, poor little word.
So when you explain, you just write that.
Yeah, well, you might want to say statistic, they're working with a sample. I like it. Okay. What's the big distinction, the way to break this four stuff down? What's the big distinction between groups of two of them? Let's talk to some of you guys. The first two are related to names. So a lot of you guys seem to think that nominal means number just because it sounds like number. We know nominal is names. Plume de nom, it means names, like French for name. Nominal, nom is the root, the real root. So nominal just means names. Ordinal is any nominal thing that has what added to it? A certain order it has to be in. Interval is ordinal things that have something added to it that subtraction makes sense. And that's why it's got to be truly numerical. I can't subtract hair colors as much as I try. And ratio are interval things that I add in two things. I add in division makes sense. And zero means the absence of that thing. I like it. So the year zero, does that mean the absence of years? The absence of time. No time has gone by. Some of you guys thought the answer was yes, that the Earth is older than 2018 years old. Right? I know this is not science class, but dear God, that has to be a known thing. Yes?
What did temperature fall under again?
Depends. The scales we normally use every day is definitely interval. Because 0 Fahrenheit and 0 Celsius, can you get colder? Yes, you can. San Diego, we might not believe that, but if anyone's ever been to Minnesota during the winter, you know it. All right, you guys with me? All right, I like it. So how do you tell between, and when you know it's a true number, like part A and part B, B's got the freaking word number in it. You gotta be careful. Like I said, a Jersey number, that doesn't really mean it's numerical, but this one is number of words. Okay, that's a measurement. I know it's got to be the upper two. And the same thing with part A, years are numbers, right? So when I see years, does 0 mean what it's supposed to mean? We just talked about that. The year 0, does that mean there was no time before that? No, of course, there's BC. So year that a wine was bottled, but can I subtract 2 years? And does the answer make sense? Not just can I, but does the answer make sense? Yeah. If one wine was bottled in 1950 and another one was bottled in 1970, well, this one's 20 years older than that one. The answer, the subtraction makes sense. Division won't mean shit here. So what level is this? Interval. Two things. 0 does not mean absence of time. And subtraction makes sense. Like 1970 minus 1950. So I'll tell you, in general, just saying subtraction makes sense. That tells me you know what the definition is, but it's not good enough. You got to show me. I'm going to say show me on so many things. Show me. Show me. You're going to be like, ugh. But yeah, you got to show me. So if you take 2 data points, when you subtract them, it makes sense. I like it. If I subtract 2 zip codes, I get a number. It works, but it doesn't make sense. Doesn't mean shit. So what about the number of words someone could type? What does 0 mean? 0 would mean that they typed, the absence of words. They just sat down and was like, what is this? So 0, so it's ratio. You could say that 0 would mean absence of words. Or you can say, you can say that, and that would be plenty. Or you could say one guy typed 20 words a minute, the other guy typed 40 words a minute. 40 divided by 20 is 2, twice as fast. Right? So you can give me the, yes?
So another reason it's ratio, because you can't type negative.
No, you got to be careful. Profit. Can profit be negative? No. All day, yes, profit can be negative. You guys are like, if you don't know, then you're in a nice blissful state. But way too many people know that profit can be negative all day long. Profit just means the amount of money flowing in. Well, if you lost money, profit's negative because it was flowing away from you, right? 0 would mean the absence of profit. Negative just means it was flowing away from you. You lost it. So it's still ratio. 0 is in the right place. 0 means absence of money coming towards you. But they could still be negatives. Don't think that negatives have anything to do with it. It's 0 in the right place, and can you divide in to make sense? Those two things. I like it. So here you could do 40 words a minute divided by 20 words a minute equals 2, twice as fast, right? So the division makes physical sense. Now this one, there was one a lot like this, I think, on the quiz. The percentages don't mean a damn thing for this problem. Because this problem, I put it in bold. Data. What's the data? What walking around keeping track of on a little list?
Didn't have the cars.
The type of cars, yeah. What was the question I would ask people for that? I'd say, what kind of car do you have? Right, what kind of car do you have? Whatever the sample was that I took, I'm asking, what kind of car do you have? What kind of car? So what kind of level is that? Just names of cars. So it's going to be nominal, just names. Names of cars. This is the data, nominal, names of cars. Lock it. All right, how are we doing so far? You guys all right? Yeah, I could be a lot better, Jeff. I'm sitting in stats class right now. So. All right. So remember, when I said discrete and continuous, I don't think I had one like this on the quiz, but I just want to put this as a general Chapter 1 review. You don't look at the number I give you, because I can round any number. I can take an average, and the answer could be anything. You say, what is it that I'm talking about in Part A? Number of people, right? What did I average? The number of people. And what can the number of people be? Can the number of people be 28.1? No. So is something wrong with what I wrote then? No. Nothing's wrong with what I wrote. Nothing. Oh, you guys are so funny. If I had 25 people, let me say that. If I had 10 families, and there were 25 kids total amongst all those families, what was the average number of kids? 2.5. If you round it, you're wrong. You're going to make it seem like there were more kids. If you make it 30, then if you make it 3, then there were 30 kids, and that's a lie. So average, since you're dividing by how many there were, it can come out to be any damn thing. People always look at it and say, hey, I have 2.4 kids average, and you can make a lot of jokes about that, and I do. But there's nothing wrong with the average being a decimal. Not a damn thing. But that doesn't make the data continuous. Good Lord, then I'm worried. Then I'm like, you think you have 2.4 kids, and that's when I don't want to come over for dinner, right? Well, I don't know, what's a 0.4 kid? I don't know. 60% Tyrannosaurus and 40% kid. No. I don't know what happened. So yeah, this would be, the number of people has to be whole number, so this has to be discrete. Number of people countable is one way to say it. Or they have to be whole numbers. Countable. So what about this one? What number has nothing to do with this problem? 50%, right? So this is what I did with the data. What is the data? What is it that I'm keeping track of? Weights of dogs. And I know I say 20, but so what? A dog could weigh any number, 19.98246621, and it would make sense. If I said 19.2468 kids, well, that's a lot of kids, but that wouldn't make any sense. I can't make it any value I want to. That's why that was discrete. This one I could have it be any value it is in between two numbers. So this is going to be continuous.
But it says under 20
What's that?
pounds.
Say it.
But it says under 20.
True, but what is it that I'm looking at? 15% were under 20 pounds. Now think about what's the data look like.
19%.
What would the data look like? And again, when I say data, think of the list after I finished asking or weighing or whatever. It would be a bunch of weights, right? I like it. And what's the possible value of one of those weights? It could be anything. So it's continuous. Could an owner say to me, oh yeah, Fluffy weighs 4.75 pounds? Of course. They just weigh them more specifically. But nobody here is going to say, oh yeah, we got 3.29 kids running around. You guys understand? You don't look at the number I give you. Definitely don't look at the percentage. Think about the thing I'm talking about, number of people, weights. Can they be anything that want to be between two numbers, or do they have to be specific? Normally like whole numbers, but not always. That's what tells you the difference between discrete and continuous. So what's time? Continuous. I love it. Right? Because thankfully, because otherwise it'd be weird if time went 0 and then nothing happened, and then 1, we go, so it's got to be a flow. Pop and lock is not something in my repertoire, so don't worry. I'm not going to try. So here you'd say, can take on any value. in between 0 and something. Let's see, question one. You take out any value between 0 and something. Whatever the heaviest dog is, I don't know. Okay. Finally down here. This one I didn't, you can't. So some people keyed on the word randomly on the quiz, and they thought, well, you gave me the answer, Jeff, but every single method is trying to be random. Random is the ultimate goal. So they all have some randomness in them. They have to. So it's only random when there's no extra process on top. The very first one, I went to every engine assembly plant in the state, and I chose engines from all of them. Some from all. Stratified. So if you say random, in one sense, that it is going to be random. It is. But it's not the right answer. You have to give me more. It's more specific than just picking them out of a hat. So this is stratified. Some from all, or some from each, you can even say. What about this guy? This one is the one. See, again, another thing is the word every, but come on. Every up here is just another name for the word all. Here, how do I use every? Every nth thing. So that's going to be systematic. Every nth foot, you could say. That's every nth is what you look for there. And part C, I say every again. But every plant is checked at randomly selected nurseries. Cluster. From some, randomly selected, all from some. Everyone from some of them. All from some cluster. I like it. Coolness. All from some. So let me give you back the quizzes.
Yay!